Hey guys, today I'll be covering heap. I'll do two questions, lead code 215 and lead code 347. The both of these want top k of something in the list, so that's either the kth largest element or the kth most frequently occurring element in the array. And the heap, okay, so when you do heap and I'll just come to this time complexity here. If you insert every element in the heap, you get a time complexity of n log n. But what lead code would say is better is n log k. Now I'll show you what I mean by n log k, n log n. I'll just start off with 215 now. This is, we're given an input array 3, 2, 1, 5, 6, 4, and we'll just go through these elements one by one. Sorting is prohibited, and what I meant by n log n, right? So people who studied heap will know about min heap and max heap. So something you could think of is, if they want the kth largest, they want us to look at this array like 1, 2, 3, 4, 5, 6, and we want k equals to 2. So we'll say, okay, we want to pick out 5, and people who studied min heap, max heap can, hopefully you thought about this, but if you just have a max heap, and let's just say it looks something like this. So if you popped off the first two elements in this heap, so if you popped off 6 and you popped off 5, you would end up getting 5 and 6, right? And 5 is the answer we are interested in. So if you technically did that, you could have the answer. But again, like I said, this would be n log n, because log n for inserting, that is the worst case for insertions, and we're putting in n, so all of the elements in the array. And this is, like, I guess the naive way to do it, and the better way would be to have n log k, right? And what do I mean by k? Like I said, log n means if we have to do insertion, we would be running through a heap based on this n, right? We would be shifting like this. That's how the heap works. And if you do n log k, what I'm getting at is they wanted us to keep k equals to 2. We just want the second element, right? So what if we just had a heap of just 2 elements? This would make things a lot simpler, right? And if we consider the input one by one with this, we'll say 3 comes in, 2 comes in, we have this. And we'll also consider it as a min heap. We don't even need for it to be a max heap, right? Because if we want the maximum, the last thing we want to stay inside of our heap is the maximum elements, not the minimum, because that's not what we're looking for. So we'll consider this as a min heap now, no longer a max heap. And we'll see 2, and then we put 3, and then we'll put 1, 2, 3. But like I said, we are only interested in a heap with 2 elements, right? Only 2. So we don't need this 1, because we're trying to keep track of the 2 biggest elements we have so far. So why would we need the 1, right? So we'll pop that off and go back to 2, 3. Then we'll take the next element, 5. 5 will come here. Do we want the 2? No, we don't want the 2. We'll come back down here, 3, 5. We'll take the next element, 6. Do we want the 3? No, we don't want the 3. We'll come 5, 6. We'll put in 4 now. 4 from here. Do we want the 4? No, we don't want the 4. 5, 6. And now our heap will look something like this in the array. And again, we've landed at the same exact answer, 5, 6, from here, and this is the 5 we were interested in, right? And as you can see, we did not need a heap of n size, right? We didn't need number of nodes to be n. We were interested in only 2 nodes, and we kept it that way. So that's essentially what optimizing this is, and we get a solution of O(n) log k. Now just to drill this in, I'll also do question 347. It's the same exact tactic, so I would encourage you to do it yourself first, and then you can come back and look at this. But if we have this array now, we'll consider the input to be this. Now this is, you can run a, like the Python library has a counter, you can use that to shorthand it, or you can just create a normal hash map and count the number of occurrences. This is still O of n, right? If you just wanted to run through everything, do that, and that would still be O(n). So that's not our problem, because we are type bounded by the idea of having O(n) log k. Since this is greater, this would always be a shadow of it, right? That's what. So we're not really trying to optimize this. This doesn't really matter. Now we have this num and count, right? Now same thing. If they say k equals to 2, we only want 2 things in our heap. Only 2 things. We'll insert again min heap, right? So we'll have. Oh yeah, wait. I'll also talk about how we should be putting these things into the heap. So some of you guys might already know this, but you can have basically arrays inside of the heap. So let's say if you have a stock, right? You have a stock exchange, whatever, and you wanted to make a priority queue, which is where heaps, I guess, will be taught to you if you took algorithms and data structures class. You'll see that the priority queues, right, they have a way of ordering things, right? And if you have a stock exchange, we would care about the price that the person is offering and the time that their order came into, right? And we would want to keep these both as a way of determining how we should prioritize their order, right? And it's the same exact thing here. We'll keep a priority with 3 and 1. So this being the number, this being the frequency that it occurs in, and the heap will sort it out for you. And now let's go back to just having 2 things, right? So when we do put in the first 2, it would look like this, and then we would have 3 1 2 2, and then we would put in 3 1, right? But like I said, we're not interested in any of this, right? Because we want the top. So we just look at these 2 once again. 3 1 2 2. This is what your heap would look like right now after you've done the algorithm. And essentially it's just that. And now if you see that we care about the 2, so both of these, actually we'll just run a normal list comprehension. So we can just run num for, this is a count, remember, this is the number. So for count and num in the heap. And essentially it's just that if you return this, we'll write. So key takeaway, we try to optimize O(n) log n to be O(n) log k. We do this by keeping only the relevant amount of heap, like the heap size should be what we actually want. We don't want to insert everything and just have to pop it off, because that would be a waste of time, right? And I'll just do a very quick run through of what this would look like in the code in case this confuses somebody. If we have this, we'll do frequency list is counter And the Python library actually has a heap queue module that you can use. It helps a lot. It does all of the things for you, so pushing, popping, heapify, stuff like that. I would suggest you just read through the way to use it, and just remember that, because it will be used for every single heap based question. Right, so what I've done here is pass it in count, pass it in as in array, like I did here. And then if the length of our heap now exceeds what we want, then we can just pop, because we don't care about the most minimum value. That's it, literally, that's it. And it's pretty much the same thing, except we're just only doing the elements in this case, right? We only have 3, we don't really care about the frequency, so just do the same condition if then greater than k. But the main thing is more so of the code. It's more about just understanding why we optimized it in the first place, right? And how we should approach heap problems. That's it.